personnel be advised, rocket discharges are armed. GSE, confirm ground side status.
GSE is locked.
Flight ops status check. Return go or no go for launch.
Fido is go.
OSM is go.
RSO range is green.
Go flight.
All flight and range ops are go. Locking in for terminal count.
Okay, there we go. Okay. There we go. Okay. All right. It's working now. This is crazy. Echo? Okay, how's that? That should be better now. Just like, you gotta be patient. Joey B, I'm getting old. I'm 25 now, so really getting up there. Alright, good. We've got a lot of goods. The chat is, boy, it's a little crazy. It's going a little wild. Alright, thank you everyone for joining. Thanks for sticking with me while I figure this stuff out. I'm usually quite good at this, or at least I'm usually better than that. I had to, figure out the audio stuff. It's fine now. Okay, no sound. Video's better. Video's bad. Okay, some people think video is bad. We should be at, 24 frames per second at least. Just let me know what you think. Rate the audio and video. As long as they're both above, a 6, that's probably what we're gonna get. I got better internet. I have better webcams coming up. This is going to be pretty cool. All right. Everyone thinks this is fine. 5 out of 5. 5 out of 7. So, what we're doing today, I'm going to have to cut this up after in the unlisted thing, but what we're doing today is building or at least we're just going to be live testing the reaction control system that I've been working on. So if you are familiar, I did a video a month and a half, 2 months ago, about a reaction control system that I'm working on. If you're not familiar, it's like a cold gas thruster system. There is a link in the description down below if you want to check that out. But we're going to be live testing it, so it might be kind of a slow stream. I don't know. We'll see. Usually these things are kind of a mess. This just came out of the printer. This is one of the RCS manifolds. So it has thrusters for pitch, yaw, and roll. We've got our inputs right here. And then we have, so you basically have pitch right there. So, oh boy, it's hard to get this aligned. Hold on one sec. So you have thruster for pitch right here. These two on the outside, those are roll thrusters. And then right here is yaw. So, okay, everyone still thinks video is okay. So, so that's what we're testing today here. The setup is a lot different than anything I've done before. We're not building any PCBs. We're not doing anything like that. So it might be a mess. Just a heads up. It might be a little bit of a mess. Okay. Buy some audio. Max effort, keep it up. I don't know how many folks have... Thank you, Anthony. That's really kind. Hold on. So when people donate, I try to put it back into the program. So a bunch of people donated during the last live stream, and I was like, all right, well, cool. Let's buy some new webcams. So, it's Joey B. I wonder if the sound is bad here. I'm going to turn it on really quick, and we'll see how it sounds. If the sound is bad here. Oh, it's fine. Okay, great. So there's a new webcam there. Let's see. All right. How's the video quality now? Let's keep rating the video quality. There's a webcam there. There's a webcam right here that's covering like other things. We probably want it to be a little bit more tilted. We've got a webcam on the pressure gauge for the compressor that we're going to be using to pressurize the system. And then this is the actual big chunky boy. This is the reaction control system. The technical term is not big chunky boy. All right, 10 out of 10, 9 out of 10, 4 out of 5 would recommend quality. Excellent. Anyway, the point of me coming over here was first to, of course, like test this system. Go down. Okay. Of course, test this system, but also to say, thank you so much, Anthony. Donations like that go towards actual equipment, like these two new webcams. So that's a really big deal. And it super helps out the project. Anyway, also thank you, Bob Hench. I saw your donation too. I didn't see your comment, I'm afraid. Let me see if I can scroll up and find it. Thank you also, Zachary Moshos. Oh boy. Okay. Bob Hench, I'm afraid your comment may have been lost in the great stream catastrophe of 2019. But thank you, Evan, as well. Have a couple more bucks for future missions. All right. The chat has calmed down a little bit. We are at 400 people. That's intense. So, let's see. We have a couple things to do here. The first thing I'm going to start with is a little bit boring, if we're being honest. I have somewhere a bucket. So this compressor. Let's get this camera over here. This is how we're going to make this work. So this compressor right here is super big. It's 4,500 psi, or it can go up to 4,500 psi. It's pretty intense, and this is what we're going to be using to pressurize our flight tank. So this is the reaction control flight tank with a disgusting mess of regulators on top. All of these regulators are going to be moved down to a more efficient solution as I refine like what parts are actually going to be flying on the vehicle. But what we've got here is all the way up to 3,000 psi in this tank is possible, although it's a paintball tank, so it's regulated, or it's like the specs are probably way under spec just because it's a consumer product and people are likely going to fill up to 4,500. Anyway, the official rating is 3,000 psi on this guy. We've got a little pressure regulator here that brings it down to roughly 800 psi. I'm also working in psi because it's like what all of this stuff is in. So sorry if you hate Imperial. I understand, but I'm using it. This brings it down to 800 psi right here. We've got this weird little like pin depressing system to actually get the pin valve to be constantly open on the tank. And that goes into our 150 psi regulator that brings it down from 800 to 150. We're coming out here. The mass flow rate for this type of, the mass flow rate for this type of tubing is all right. Really, the big limiter for mass flow rate right now is the reaction control valves in the actual flight vehicle. But I don't know. It's been actually it's really been hard to find valves. If you're a valve company, please reach out. I need help. I need better valves, and I cannot afford the quality of valves that I actually need. Okay. Anyway, what's going on in the chat? Thank you, Tyler. Thank you very much. Wow, this is crazy. Hey, we're also going to do space trivia. Okay, so I have so many things to cover. This is a mess. I hope everyone enjoys tuning in to just like watch Joey B freak out for the first 20 minutes every time he streams. We're going to do space trivia today. It's going to be themed on the Saturn family of rockets. So that is the Saturn 1, the Saturn 1B, and the Saturn 5. That's what we're going to be focusing on. It's going to be really cool. I have a bunch of questions ready to go. We might be able to take a couple others that I asked for on Twitter. If you're not following on Twitter, you should. And what else do we have? Oh, also, if you're going to miss this stream, not to like drive people away, because I hope I don't do that, but if you're going to miss this stream, it's okay. I'm actually going to be putting together a better and like more, not better necessarily, but a more concise version of the testing that I'm doing today, that I did Sunday, and a couple other days. And that'll be just another RCS update in the next few days. Okay, RCS. So the first thing I have to do is kind of baby this little compressor here. So this guy needs a water pump to pump water through it while it is actually compressing air up to 4,500 psi. It gets really hot. It's a kind of a hydraulic pump, but it gets really, really hot, and so you have to treat it real nice. And that means putting a bunch of ice into a bucket. Also, hey, thank you, Gavin. I unfortunately missed you at Narcon, but these live streams are just too cool. Keep it up. Thank you so much. That's really kind. All right, so stay tuned as Joey B gets a bucket and then dumps ice into it. It's a very exciting event. Don't go away. You won't want to miss it. Okay. It's also, this is going to be kind of a loud stream, I think. Yeah, I just get the vibe that this compressor is really loud. I had to check with my neighbors. I just like, out of a little bit of fear, I checked with my neighbors before actually committing to do this stream today, because this compressor is tremendously loud. Like, the thrusters are loud, but that thing is the real offender. Okay, so here we go. Ice in the bucket. Let's see if we can get a good angle on this. I've got all these cameras, like you might as well. All right, here we go. Ice in the bucket. Now we need water in it. Isn't it great that all of these things are happening off camera? All right, hold on. All right. So that's going to take about a minute to fill up. We'll do a couple more, I hope you can hear me, it's kind of loud. Ad Astra, everybody. RIP headphones. Need more cameras. All right, let's start doing space trivia while the old bucket is filling up. So I have space trivia. I hope the mic is okay here. I have to bring my space trivia up. I have a whole Google Doc for it. So once again, we're going to start off with the Saturn family of rockets, and I think we'll start off on the Saturn V. But hold on one sec. Okay, we're almost full. That's probably good enough. So our bucket now has a bunch of water in it. You can kind of see it on this camera. Maybe you can't. I don't know. I don't know how cameras work. And then we've got this little pump right here. The pump needs to go in the bucket, full of ice water. And if we turn the pump on, you should probably be able to hear it. Get real quiet for a sec. It's working. All right, cool. Now I don't think you can see on the on the camera here. So this is the compressor right there. I don't think you can see it on this camera, but right there there's a temperature gauge in Celsius. So the pump is 20 degrees Celsius. Now it's 18. In a second it'll update as we keep pumping ice water through it. Now it's 17.2. Yeah, so the pump works. We're definitely circulating water through there, and it's definitely cooling things down, which is what we want. Oh, thank you, Chris. Hi, mate. Thought about using 2 of your BPS boards to stop horizontal drifting. Oh, have you thought? I think it's a question. Have I thought about using 2 of the BPS boards to stop the horizontal drifting? I'm not sure that would do too much. I guess you could do a little bit of error checking between them on the sensors, but I think you can fix most of it in software and just proper calibration. Speaking of calibration, Chris, this is a great segue. Thank you so much for asking this question, because we need to, what is all of the Kahoot? What is a Kahoot? Can someone explain what all of the Kahoot in the chat is? I don't know what this is. Chris said something about calibration. Oh, okay. Chris gave us a great segue into calibrating, and we need to do that on the relay vehicle. Oh, it's a quiz thing. Kahoot. What is Kahoot? So it's a quiz, it's an online quiz thing. Well, we're not doing Kahoot. We're doing Joey B trivia. And if you don't like that, you can unsubscribe. Please don't. Okay, I'm only kidding. Let's start off with a trivia question. We're not going to do Kahoot just yet. Maybe in the next stream, but I don't have that figured out. And I tried so many new things for this stream, and all of them broke all at once when the audio didn't work. So we kind of know how that went. Okay, so, ooh, I hope you can't see the answers on that camera. Hold on. That's where, okay, yeah, you can't really read them. So I'm reading it all from a Google Doc. There are no real points here. This is the first thing to say. There are no real points in this space trivia thing. There are only fake internet points. It's like Reddit points, right? It doesn't really count. So they're going to be themed once again around the Saturn family of rockets. And specifically, I mean, it's basically the same thing. Most of their stuff was for Apollo, but a lot of it is going to also be in relation to Apollo, the Apollo missions. So we'll get started here. You have to get it right, and the first person to get it right wins. And they don't win any point, or they win a point, but that's it. All right, ready? Here we go. So the Apollo guidance computer is a computer that did guidance for the Apollo command module. The question is, ready? The first person to get it gets it right. What frequency did the Apollo guidance computer operate at? Okay, now we're going to wait. We're going to see what the answers are. We're going to see who gets it. Someone's going to get it. Jack? No. Nope. No one has it yet. Oh man, there's a lot of answers. Hold on. I think someone got it. There's a lot of wrong answers here. Alright, hold on. I'm scrolling through to make sure I don't miss. Okay, someone definitely got it, but I want to see the first time. Oh, this is a mess. Okay, hold on. I think the first person who got it is, someone said 2 hertz. Martian Lemon said 2 hertz, and I feel like that would be somewhat slow. Francisco Tarita gets it. A round of applause in the chat, please, for Francisco Tarita. I hope I'm not butchering your name there. The answer is 2.048 megahertz, and he gets it. He used a comma, but I'll count that. And then let's see if there's a second place. Okay, a bunch of people got it after that. All right, well, thank you, Francisco. Good job on all of the cameras. This is a mess. That's our first question. Thank you, Francisco. I'm going to write your name down. Francisco. I don't know what I'll do with your name. I want to like log that you won it. All right. Thank you, Remy, by the way. So you can get a lapel mic on Amazon. Thank you a bunch, Remy. I actually have a lapel mic. I'm curious like what the best solutions are for a lapel mic during a live stream, and I think because I move around the room, it would be good to have like a wireless lav. you know, something that I can really forget to turn off when I go to the bathroom, that kind of thing. That might be the move. All right. So, all right. Wow, we're almost at 500 people. That's crazy. Maybe if some of you want to leave to like put a little less stress on me, that would be excellent. So, Anthony earlier mentioned something about using 2 computers for higher accuracy. And that's not what we're doing today, but it's kind of in the same vein, which is that we need to calibrate this vehicle before we start testing. So, I'm going to tie a bit of a knot here. Not a very good one. Not a very good one. And it just needs to hold the vehicle. I'm going to tighten it all down. And we're going to calibrate the rocket. So, mostly what we're looking to do is calibrate the accelerometers on the vehicle. And this isn't something you have to do every time. I just haven't done it for this flight computer yet. So the flight computer needs to have a good sense of which way is directly upright. Now, oh, there goes my ice machine. Making more ice for me. The flight computer is already in the vehicle, so we're going to hang it from here. And the way we do this is we hang the vehicle upright, or pretty close to it, close enough. And then while it is hanging there, we're going to let it just sort of drift. I'm going to put it into the idle mode. There we go. So it's starting up. And then we're going to wait for it to stop moving. Okay, I will need my phone for this. Oh man, we're almost at 500. We need one more person. Someone invite a friend. One more person. Oh, 504. We did it, folks. All right. So what you won't be able to see the screen on my phone here, but what the phone is doing is showing live data about what's going on in the rocket. And sorry, you can't see the phone. But anyway, right now it shows that the rocket is at 0.7 degrees pitched over, and that is incorrect because of how gravity works. So I'm going to go ahead into the accelerometer page. Again, sorry you can't see this more clearly. It only has to happen once, so it's just going to be fine. So here we go. I'm going to calibrate the sensors. You can hear it. And then it's going to start beeping when it's done again. Cool. So now that we've calibrated, let me just make sure everything looks good, and then we can get started with the testing. Yeah, cool. We are basically zeroed out. Okay, that's good. So the vehicle is calibrated. I'm going to turn it off again. And the other thing I have to do is load a slightly new flavor of software on there. So I'm going to take this off, and we're just going to load new software on real quick. And this is basically going to start, the software is going to force the vehicle into the flight sequence right around the time that it's going to, I'm so good at live streaming. It's going to force the vehicle into the flight sequence about 15 seconds after startup. And so usually the flight sequence would be, it's like how Signal works or how ARC works or any of the BPS flight computers. Basically, when launch is detected, all of the active control systems are armed. And so, yeah, anyway, that's what we're going to do. Got a little loose rubber band in here. That's no good. That wouldn't pass quality control. So I need a quick USB cable. Boy, to all 525 people watching right now, I know this first part is boring, but I promise it gets better than this because it's going to get really, really loud real quick. I have to turn this so you can actually see what I'm doing. So I have the flight software here. We're just going to go ahead and load it up. It is all coded in C++ in the Arduino IDE, if you are wondering. And once this is loaded on, then we can really get started. Compiling, and we're just going to upload now. I'm going to set it to 20 seconds. All right, we're uploading the flight software. Oh, no, we're not. Hold on. Okay, now we're uploading the flight software. Let's see what's going on in the chat. Joe, where is the sad plant? I'm afraid I don't know what the sad plant is about. Wonder when. Oh, okay, cool. We're uploaded already. Joey B, use Arduino dark mode. You know, Orion, I tried the Arduino dark mode, and it just didn't look as nice. It looked like a weird impersonation of Xcode in dark mode. Xcode in dark mode is like gorgeous. Okay, great. So we are all ready now. I'm going to turn this camera back so we can see what needs to be seen here. Okay, and the next step is to mount the gimbal mount on the table. So this is what the rocket is going to be sitting in when we're actually testing. So we're nearing the testing time. Maybe like 5 minutes? I don't know. Maybe a little longer, because pressurization takes a little while. And I think we'll do a couple of tests. The first thing to note is the test runs are going to be pretty short, just a couple of seconds each before we basically deplete all of our working fluid in the flight tank, but that's fine, because most of these flights, at least to start, are going to be short too. So I'm going to put the rocket into the gimbal mount, grab this guy, and okay, mounted there, and here as well. Okay, so we have the vehicle mounted. You can see, unscrew this just a little bit. So you can see it's pretty free along both axes. We have both yaw and pitch here. Now, the thing to note is that, okay, so there's a little bit of friction in the gimbal mount, but it's enough that the vehicle can certainly overcome it. And what you'll also notice is that the center of mass is above the rotation points on both axes. What this means is that the vehicle is always going to want to flop over to the side, and our goal is to keep it upright. And usually you'd want the gimbal point directly at the center of mass. That's how it will work during flight, with some exceptions depending on how fast you're going and how powerful your fin control is. Anyway, we are going to set this so it's actually going to be harder for the vehicle to control itself in this mount. We're working with a set of PID gains that I got from a flight simulator that I built in MATLAB and Simulink. And we're going to go from there. And I need a glass of water first. Hold on. Okie doke, everybody. Oh, thank you, Michael. Mosseri? Michael Mosseri. I think I got your name right. Everyone, can we get a round of applause in the chat for Michael? Or either a round of applause or just say thank you, Michael. That would be great. All right. So, now the next thing that I want to do here, this rubber band is going to drive me crazy. The next thing that I want to do is hook up the airlines. So once again, these are just like really basic flexible tubes that we're going to be working with. The first place that they need to go is in the bottom of the rocket. That's the air supply. We are not working with the flight tank on the build just yet. One step at a time. All right, so we're all hooked into the rocket. We may do some leak tests as well. We also have, this is our working fluid shut off and turn on. So this is really good to have. Plug this into the regulator for the flight tank. Once again, this is our flight tank. It's just a regular old paintball tank. And then finally, hold on, this is a mess. That goes there. The quick disconnect for the flight tank is in, and so we're just about ready. Yeah, so this is our test setup. If you want to follow along, basically what happens, all of the air comes in from a little manifold that you can't really see right here through this 4,500 PSI compressor. It goes through this line, through the quick disconnect to the flight tank. Now that this is a one-way valve to the flight tank, so basically you fill up the flight tank to about 40, well, in our case, we'll probably start at about 1,000 psi just for really short tests to make sure that everything's working right. We'll start off at about 1,000 psi. That gets regulated down to 800 right here. Can you see this on the camera? No, you can't. Hold on. Let's make sure that everyone can follow along with what's happening here. Yeah, so we go down to about 800 psi in the tank. 800 psi through the first regulator, 150 after coming out of the second regulator. That goes through our working fluid shutoff valve, and then that goes into a manifold inside of our test vehicle here, which goes up through two different sets of valves. We have the X positive and negative valves right here, and then the Y positive and negative valves right here. Flight computer is right here. The manifold is right here. Future vehicles are going to have the manifold integrated into the nose cone like this, but one step at a time. That's a lot of information. What's going on in the chat? Bob Hench says, what is this system going to be flown on? Well, the snarky answer is a rocket motor, but I know that's not your question. Right now, it's probably going to be a high-powered vehicle. It's going to be difficult to get this light enough to fly on just low-power motors. If you cluster them, it would certainly work. But I guess the true answer is I don't know until I can fix the disgusting regulator situation on this flight tank right now. We need to take all of this and compress it down to just one regulator. I actually have the regulator to do that. Hold on. Right here, I have, hold on, this is the regulator. This little component right here, this little component, is going to replace all of this mess. So I have the regulator to do that. I just don't have all of the fittings yet for it, and it is, that's like the most expensive part of the whole process is the, that's the most expensive part of the process is getting all the fittings and stuff like that. And then getting it wrong like 3 different times. Oh man. That's a big microphone, says Gavin. Thanks, Gavin. All right. So should we do it? Should we do the compress? When we do PCB assembly, we do the melt. That's when we melt the solder. But I think in this case, we're going to do the compress. So what I'm going to do here is I'm going to set up a couple of cameras because I'm also filming this for the full higher quality video that's going to come out in maybe a couple of days. I'm going to get a camera and point it at one of these pressure valve, oh my gosh, what's it called? Pressure, hold on, there's a lot of dinging going on. Pressure reading things. What is this called? Pressure readout. That's what we want. So I'm going to zoom in here. I know this is super exciting to watch. This is just, riveting content. So let's get this going at 24 frames per second. Get it in focus. Make sure the white balance looks good. Okay, great. That looks fine. And then I'm going to put a larger camera up here. This is the benefit to doing wedding videography before you start doing rocket work, because you end up with a lot of cameras that you get to use for this stuff. All right, let me just set this up. Once again, I know this is really exciting to watch. There's just nothing better than staring at a screen with nobody on it as they set up the camera. All right. I should let you know now that I don't have a whole lot of expectations for these first few tests. I think it might be a little bit underwhelming, but we're going to do it anyway. I have one more camera to set up right here, and then we will be all set. And make sure this is in the right frame rate. 24. I also need to, oh my gosh, I need to get a cable to plug it in. If this is not your bag, if this is not the type of content you subscribe for, I'm going to let you know, it doesn't get too much better than this. It's like a lot of setup for about 6 or 7 seconds of payoff. So let's go ahead and plug this guy in so he doesn't die. All right. All right, that's ready. So we are just about ready to go. Let me make sure I didn't miss anything here. Okay. I think we're ready. So right now, what's going on is we are in the shut-off position. So we're only going to be pressurizing our flight tank and the piping before the working fluid shut-off. And then when we're ready, we can turn it on and listen for leaks. There are probably going to be a couple of leaks, and that's okay for ground testing. It gets less okay once you are waiting on the pad for a long time with a pressurized system, but that's what we're going to do. So let me start rolling on all these cameras. Rolling, rolling, rolling. I guess you can't really roll on a digital camera. You mostly just like start recording. But I don't care. It's my live stream and I'll say what I want. All right. The first step here, it's a very tedious process. First, we need to turn the pump for the water cooling on. So here we go. Oops. All right. Water cooling is on. Next, we need to start the pump. And I'm going to walk you through this before it happens because you won't be able to hear me until the pump shuts off. It's that loud. It's awful. Maybe, okay, listen, if you're using headphones and you can hear me right now, maybe take the headphones off. That's my recommendation. And I'm going to try to keep communicating by putting my mouth like right up to the microphone, and we'll see if that works. I see a comment from Tom Mix that says, bet his neighbors love this. I don't think they do, but I did warn them, and they were like, yeah, it's fine, just do what you need. So, here we go. I'm going to try to keep communicating, but we'll see what happens. Oh, the next thing too, I know this is like a huge build-up to what is basically just loud noises. Anyway, you're going to see this gauge start to go up. We're going to bring it up to about 1,500 or 2,000 PSI before we shut it off. And you also want to start this pump. It's a little bit delicate. You want to start this pump with all of the like relief valves open. So the pump, when you turn it on, will not actually be pumping anything. It will just be, or it'll be compressing air, but it will be compressing air and then just putting it back into the environment. So then you close the leak valves as the pump is already on to reduce stress on the pistons inside. That's a lot of information. I'm really nervous. I've done this before, it's fine. But I'm like nervous. All right, here we go. 3, 2, 1, loud noises. Okay, now I'm gonna turn the leak valves off. And so we're pressurizing now. You can see the needle go up. Okay, and we are pressed. That was exciting. Just to give you a sense, so the pump has now reached 40 degrees Celsius. It was idling at 10, so it gets really hot really quickly. Some people say we can hear you, so all right, let's get a sense for where we're at right now. We are at 2,000 PSI in the flight tank, and because of PV equals nRT, the flight tank is warm. Okay. So now we're going to pressurize the system, and we will probably hear some leaks. So here we go. We'll Let me turn off my AC so it can just be a little bit quieter here. The water pump for this pump is still on. Let's wait till it gets below 20 Celsius and then I'll be cool turning it off. Just because I want to hear all of the leaks and I want you guys to be able to hear it too. Oh boy. All right. Did I mention where it is? I think I did. So we're at 2K right now. I think we're falling just a little bit, so we're probably more at like 1.8. So that's 1,800 psi, 1,800 pounds per square inch inside of this flight tank. I will go ahead and disconnect. Yeah, we're depressed. Okay, cool. So I'm going to disconnect the quick disconnect. So now the flight tank is on its own. And we are at 17C on the compressor. So the water cooling is off. Thank you, Steve, and thank you, Jason. Oh, Steve says put safety glasses on, and that seems like a good idea to me. Thanks, Steve. Safety first. Hey, Joe, are you planning on using movable fins like New Glenn to steer in par with your reaction control system to control higher powered rockets? Jason, that is a good question. The answer is not in conjunction with the reaction control system, but I do want to do regular fin control or like active fin control later on in the summer. I think it would be a fun project to take on. All right, our flame tank is holding quite well at about 1,800 psi. So now, I think it's time to test. Is everyone ready? So we're going to pressurize the system, listen real close for leaks. You can turn your headphones back up if you want. Okay, yeah. So you can hear there's a little bit of leaking. That's not too bad though. We're down to 1,500 psi, so we're definitely leaking. I'm going to go ahead and close this. And the leaking is stopping. So this is our flight press valve, basically. All right. We're going to turn the computer on. I'm going to hold it here, and then after about 20 seconds of being on, we don't get a whole lot of warning. I should probably put a better warning in the flight software, but after about 20 seconds of being on, we're going to start the reaction control system. Let me double check the cameras here, because a lot of this testing is, I also want it to be documented as we go forward. That camera's rolling, this camera is rolling. Let's power up. All right, so we're on. Okay, we're idling, and I'm going to press. We're pressurized, and it's going to start in just a minute here. All right, here's a good lesson. Hold on. Do not put rubber bands in front of your valves. We also ran out of pressure pretty quickly. So I did tell you it was going to be probably overwhelming for those first tests, and we're going to do more. So let's go ahead and pressurize again. I'm going to turn the water pump back on. There we go. We're going to wait for this to drop below like 17 there, and then once that happens, we will pressurize again. Hey, it's Charlie. Hi, Charlie. Eric says there's a few people here, and Eric, you're right. 670 people. Woof! I'm not nervous, it's fine. All right, we're at 18 Celsius, 17.5, and once we go below 17, I'm gonna pressurize again. Still a little pressure in the flight tank, but that is okay. All right, here we go. 3, 2, 1. Watch that again. Right here. 2.5, which will probably sink down just a little bit once again because of how POV works. PV equals NRT. It's probably going to go down just a little bit, but we're at 2.5. We're open on the compressor, so I'm going to disconnect, the quick disconnect here, check the cameras one more time, make sure that's in frame. Okay, cool. We're still rolling on all cameras, I believe. Oh, thank you, Alex. My monthly $2 super chat for Awesome Rockets. Thank you very much. All right, so we're going to give this another shot. If you're not familiar with how this works, basically we're going to power the computer on, and then we'll let it do its thing. Hopefully it'll work a little better than last time. Okay, and I'm gonna press for flight here, and we're pressed. Yes! Wow. Smash that like button if you agree. That was super cool. Wow. All right, let's do it again. Oh, jeez. That was so long. How many seconds was that? That lasted forever. I need a drink of water. That's incredible. Our ice is all gone, just to give you a sense for how temperature works. Our ice is all gone. It has been, the energy that the ice was storing has been absorbed by the compressor. All right, we're gonna do it again. I'm wondering what we think we should change in the control system. Ooh, ouch, pinched my finger. So we still have leaks in there. I think the leaks won't be great. I think something that might be kind of boring, maybe we'll do another live test here and then we'll do another boring test. I'd like to see how fast these leaks are affecting the tank pressure. And so what we would do is bring it up to like 2.5, 2.5K, 2,500 PSI, something like that. Open up the press valve and then just like give it 30 minutes or 20 minutes while we do space trivia and see how far it goes down. So we can like characterize how those leaks are affecting the rocket. All right, should we do another one? Let's get some applause in the chat for the relay reaction control computer for doing such a great job. Let's do another one. The compressor is down to 16.7, which does meet my rule of not starting until we're below 17. So, once again, we're going to hook up the tank. The tank is connected. Right, we're off on the press valve, and let me just make sure, yeah. Okay, are we ready? Oh my gosh, lots of applause. Thank you, everyone. Here we go. Compressing to, we went to 2.5 last time. Let's just go to 2.5 again. I don't want to push it too much. 2.5 again, here we go. So while we're pressurizing for flight, let's do some space trivia. How tall is the Saturn V in meters? Somebody's leaking. Okay, it's a leak in... It's a leak between... It's not a leak from the tank. That's good, which means it does make it to the 800 psi regulator. It's leaking between the two connections. Okay, that's fine. We can leak there. It will ruin our... Well, we can just tighten this down or put more Teflon tape on there or something. Let's see who got the Saturn V question right. All right, so Nathan, you are really close. Nathan Kearns was very close, but you had to be exact. Oh, Matthew Newell. Matthew Newell. Let's get a round of applause for Matthew, who got it right at 110.6 meters. Very nice. Hey, Bob. How long do you think you will need to maintain control on the rocket? From Bob Hench. Bob, great question. It really depends on the flight profile. If you're going to space, you need a lot of control. If you're going to 100 meters, not that much. The other thing that I have to factor into a lot of this stuff is okay, yeah, we're definitely leaking a little bit. The other thing that needs to be factored into a lot of the flight profile planning is making sure we depressurize the whole system before it reaches the ground. That's a little bit overkill, honestly, for model rockets, but just as a demonstration of that I take safety seriously, I want to basically, as soon as we reach apogee and we no longer need control, I'm going to open up all of the valves and let it bleed, or at least open up as much as I can safely open up at one time to bleed out the whole system. So it's going to be a lot of ground testing, and then we'll just fill the tank for exactly what the flight needs, plus maybe 30% margin and plus whatever we need to get over any system leaks. Okay. Are we ready? Have we lost viewers? Not really. That's crazy. Thanks everyone for joining. If you're about to leave, don't, because it's going to get real cool real quick. So yeah, we've drifted down to about 2100 psi now. Once again, yeah, we're definitely depressurizing the tank. So we're at 2100 psi in the flight tank. I'm going to move this into view of the camera and restart these cameras here. Hold on one sec. This is pretty useful for once wow, I can't say anything today. This is going to be useful for the video that comes out in a few days where I show you what the updates are to the reaction control system, which will be better than a live video. Okay, great. So we are rolling on this camera, and I'm going to re-roll on this guy as well. Okay, we've got a camera on the pressure, and I think we're ready to go. Is everyone ready? Also, I'm so sorry if I can't answer your questions in chat right now. I think maybe we'll do a little BPS after hours or something like that, where once the chat calms down a little bit, but right now we have some reaction control systems to test. So, I'm gonna disconnect the quick disconnect. You don't really need to do that, but I do it anyway. We're still in focus. Make sure this feels good. Cool, so pressurization works. This is gonna be a shorter run than last time. We're gonna turn the flight computer on. Starting up. Maybe we'll start at a little pitched over angle here. All right, and pressurized. And definitely leaking a little bit. Oh. Press F in the chat, please. It's pretty cool, though. All right. That is all well and good. Should we run one more? I'd like to tighten this up just a little bit before we run more. So now we're just draining directly from the tank. All right. How tight is this? 1 second. Sorry, relay. I bumped you. We're just gonna make sure this is all the way. Yeah, okay. The way to fix this is gonna be Teflon tape. Yeah, these are all the way tightened. And so I will need Teflon tape to fix that. Wow, look at all these rubber bands. I don't need any of these. All right, what do you think? Should we run one more test? I think we should run one more. Oh, the tank is cold now. The tank is cold because of nerd. We're gonna go up to 3K now. So 3,000 PSI on the tank, and then we will run pretty quickly after that. So I'm gonna close the press valve. Oh, thank you. Oh my gosh, how do I pronounce your name? Mithrikia. Well, thank you either way. I'm very sorry that I can't really figure out your name. Have you considered using Have you considered using chemical gas generation for the reaction control system, i.e. like hydrogen peroxide or something like that? Can be kept idle until required and it's compact and light. Correct on all accounts. I have not considered that because I just like the idea of using a resource that is all around us to actually fly this thing. So all you basically need is electricity and a little bit of hydraulic oil. It could work, but I would rather deal with high pressures because I think that's kind of cool. All right, so let's do another test here. What do we need to do? So the compressor is down to 17.2. We're really running out of cold water here. It's still cold, it's just not that cold. All right, so we're connected. We're closed. And we're gonna pressurize. Is everyone ready? I'll do another, I'm gonna do another question while we're pressurizing. Watch out for headphones, by the way. So we're gonna do another question for pressurizing. This one's gonna be pretty specific. Hold on. Let's see. Okay, I think, yeah. So this one I'm pretty sure about. I was told about it on Twitter, I believe by Ian Atkinson, if I'm getting your name right. All right, ready? You're gonna get the question once we start pressurizing. We're gonna go to 3K PSI here, and then while that's happening, get ready to answer this question about the Saturn family of rockets. Here we go. Oh, right, don't start that way. Okay, we're down to 17C. Here we go. 3, 2, 1. All right, we're pressing. Out of the 3 Saturn I pads that were built, which one was never used for a launch? $1,000. We're definitely leaking. I'm going to get to these answers in just a second, but we have to start now. So, I want to use all 3K PSI pressure, so we're going to start up here. All right. We're going to start over from this pitched angle right here. And then we're just going to let it start. So 3, 2, 1, and pressing. We're pressed. Couldn't quite get all the way up. Yeah, there's not a lot of pressure in there now. Okay, I have an idea of what's happening here. So the mass flow rate is still pretty limited by the tubing that I'm using, and if both valves are actuating and both valves are sending up pressure, the regulator may not be able to keep up. This is still a pretty low flow regulator, so it may not be able to keep up and keep the supply line at 150 psi. So if both valves are draining it at once, I think we end up losing the amount of pressure that we need to stabilize the vehicle. Because as soon as it got beyond a certain point, the valves are still on. As soon as we got beyond a certain point, we were not able to keep the vehicle upright. And the same thing you saw with when it turned on, it was trying to actuate both valves at once from a really big pitched over angle. So I think that's something that could either be dealt with in software, or the actual fix would be just providing the hardware that's needed to provide that mass flow rate. Okay. Wow, it's kind of a lot of info. So we're open here, we're closed. I'm gonna disconnect the vehicle, open, disconnect that. All right, great. Let me turn off these cameras, turn on my air conditioning because it's very hot in here. Thank you, compressor. And then we will get back to the space trivia. And we'll probably do some more reaction control tests too. All right, that's good. The air conditioning is on. So, the question was, excuse me, Rocket. The question was, out of all of the launch pads built for the Saturn I, which one was never used? So, all right, let me see if I can get to where this starts. Okay. I don't know what to I suppose I should have. Yeah, so a lot of people thought this was about Saturn V. I don't know if it was clear, but this is about Saturn I, not Saturn V. So the answer is not Pad C. These are good guesses, but I don't see the right one yet. Hold on. 1339. Nope. Nope. These are the pads which were not built, not the one that wasn't used. Oh! Okay, I think we have a winner. This is for the Saturn I. Yuval Litvin gets it. Good job, Yuval. The answer is pad 37A. This is for the Saturn I vehicle, not the Saturn V. So for the Saturn I, there were 3 pads built. Which one was never used, for a launch at least? And it's LC37A. So thank you, Yuval. Good answer. You got it. Okay. Let's do some more space trivia. Or I guess, what should we do now? Put it in the chat what you think I should do now. The reaction control system looks good. I mean, I'm just learning stuff as we press the vehicle and see how much we can actuate to. I think the D term might be a little aggressive on this. I mean, there's more simulation that has to be done as well. We could play with the PID games, I suppose. But let's look at the chat here. Oh, thank you, Alex. Have I considered visiting the Balls event? If you're not familiar with what that event is, that might sound weird to you. But it's a high-powered rocketry event out in either the Black Rock Desert or Mojave Desert or something like that. Every September. I really want to go. I've wanted to go for 2 years. I just can never justify spending the money to get there. But I would like to. But maybe this year. Who knows? Okay, people want more trivia. So, are you going to sell the reaction control system? Not for a long time. Maybe never. I don't know. It's quite it's quite a lot of work to develop. So, more trivia, everyone. More trivia. During Apollo 6. Oh man, I shouldn't have even started saying this. The first person to get both of these right, listen close. The first person to get both of these questions right, it's a two-parter, and you have to put the answer for the question. You have to put your answer as one chat. You can't answer one and then the other. I won't count it. You have to put so you have to wait until I finish asking the question, and then you will get it. All right, you ready? So, here's the question. During Apollo 6, something happened to a few engines in the second and third stages. What happened? That's the first one. And second is, how was the problem fixed? So you have to answer both of those things correctly in one chat. So once again, during Apollo 6, something happened to a few engines during the flight in the second and third stages. What happened, and how was that problem fixed? All right. Atlas walked away and said, it was the butler with the candlestick. I'll give that a half a point. That gets a half a point for sure. All right. So far, no one has... this one's good, Ben. 1, it blew up. 2, don't blow up. Okay, hold on. Someone's... I don't think anyone's quite getting it. It has to do with some of the piping. That's the solution. People are getting the first part, which is pogo oscillation. I mean, I assume the problem was fixed by multiple parts, so... No. Didn't fix it by extending the burn. It malfunctioned and they fixed it. They did not fluctuate the thrust to fix it. Cold valve, a pipe broke. Oh, okay, this is pretty close. Stephen Van de Kamp, you're pretty close. You're not all the way there. Stephen says a pipe broke and they fixed it by using stainless steel. You're kind of close. Oh, hold on. Charlie, I trust you on this answer, even though it's not what I have written down. All right, we might have to call this one just a dud. What I have written down as my answer from reading about it online is that the several engines shut down because of several things that happened, but ultimately it was because of pogo oscillation, which is where the rocket kind of acts like a pogo stick. The engine gets more thrust, and so more fuel is forced into it, and it's this huge, big oscillation up and down the vehicle. It's bad. And so they fixed it, at least in my mind, the way they fixed it was by using they had flexible lines, they had flexible fuel lines into the igniter for the engine, and they fixed it by turning those flexible lines into just rigid stainless steel piping. Let's see. Yes, I think that's what the answer is. I think we might have to call it a dud because I probably should have done more research on that. Let's just pretend that didn't happen. Oh, U.S. water rockets may have gotten it. He said, I said flexible pipes. Yeah, that might have been it. U.S. water rockets, you get a half a point. You're always in these live streams and hanging out in the chat, so you get a half a point anyway. The points don't matter, by the way, but let's do another one. All right. Here's another question about the Saturn 1 and the Saturn 1B. So, once again, first one to get it right is the winner. What? I'm going to try to say it fast. What was the success rate for the Saturn 1 and Saturn 1B? Cumulative. Someone's going to get it. Someone said 42. That's correct. Nope. J.R. Kraft gets it with 100%. That was kind of an easy one. A lot of 69%. That is incorrect. Let's do another one. Let's do more. All right. So all right, ready? So once again, first person to get it right wins. And this is once again about the Saturn 1, not the Saturn 5, the Saturn 1. The S1 first stage used what engine built by what company? You have to answer both in the same thing. Someone's going to get it. Oh, Jaden Walters gets it with H1 and Rocketdyne. Very nice. Good job, Jaden. This is great. A lot of people are getting this. Wow, okay, everyone is getting this. So the game is really like, how fast is your internet? That's really the name of the game here. It's less trivia and more just like, how fast is your internet speed? Okay, let's do one more, and then I think we should go back to reaction control testing, because I'm kind of missing that. All right. So here we go. This is another two-parter. Well, okay, no. Let's do another one about the S1. So this is the Saturn 1 first stage here. Ready? First one to get it right. And you have, okay, this is a two-parter. You have to say the number. This will make sense in a second. You have to say the number and some way of indicating the location of these engines. You'll get it. Here we go. On the Saturn 1 first stage, there were 8 engines. How many of the first stage engines could gimbal? Someone's gonna get it. Oh, there it is. Jaden with the slam. Okay, Jaden, you might have to be disqualified. I think you have good internet here. Jaden with the slam. Hold on, I missed it. 8. Okay, 8, 4 inner and 4 outer, which are gimbaled. Yes, correct. And J.R. Craft gets the secondary point on there, which is 8 total and 4. Yeah, okay, great. So let's do one more. I can't stop. I love this so much. We'll do one more here, and it's another two-parter. Actually, it'll just be a one-parter. The two-parters are pretty hard, and it's a lot easier to just type, a couple letters and then hit slam enter. All right. So once again, this is not for the Saturn V. This is for the Saturn 1. And specifically, here's the question. Ready? First person to get it. The same company built the guidance system for the Redstone and the Saturn 1, but flights... Okay, what company built it for flights 1 through 4 of the Saturn 1? It changed after that, but which company built it? 1 through 4 of the Saturn 1. Nope, no one's gotten it yet. IBM is not correct, Lockheed is not correct, not Rocketdyne, it's not Aerojet, it's not Marshall. Oh, wait, someone get it. Somebody get it. Hold on, let me just make sure this is truly the first one. SpaceX did not build the guidance computer for the Saturn 1 in the 1960s. Good guess, but no. Oh man, it keeps scrolling down. Someone did get it. Let me just make sure I get the name right. Jeff Welder, you are our winner for that question. Clap it up for everyone for Jeff Welder, who said Ford. That is correct. The Ford Motor Company built the guidance computer for the Redstone missile and the Saturn 1 rocket. Which, by the way, the Saturn 1 was considered for the purpose of being a missile or ICBM, but then they were like, oh, maybe not. Maybe we better don't. Okay. Let's do some more RCS testing. I think I'd like to, before we get started, I'd like to change the D gain on the computer in the PID controller, which, by the way, PID is not the right way to do reaction control systems. It's just a saturated and gated PID, so it's a pretty dumb control system. It does work, but you can see that there are just weird oscillations, and you really want it to be torque-based. I'm going to talk about that a lot in the upcoming reaction control video. We're going to change the PID gains in the system. And here's my question. Do I go up? Do I make the D gains, that's the derivative gain, in the PID controller? Do you want it to go up, or do you want it to go down? The up is going to result in a more aggressive and faster correction, but it's probably going to oscillate more? Or should we go down, which is maybe a bit more tame? Okay, there's a vote for up, down, up, left. U.S. water rockets, left is not a correct answer. Disqualified. Down, down, up. Wow, it's kind of split. Landon Bowler says both, and he is right. I guess let's just do both. Let's just jump into it. I have to put my phone really close to the computer to actually control any of these things because the antenna that I designed for the Bluetooth chip is just awful. It's like a terrible antenna. Let me screen cap what this is. I'm going to take the D gain from 0.012 to 0.009. Oh, shoot. Hold on. I didn't do it fast enough. The computer fake launched itself. We're going to go down, basically. We'll go to 0.008. So we're going to go down first. 0.008. Great. So this is going to be a lot more tame than the last flight. I'm not sure if it will actually work, but we'll see what happens. That's what we're here to do. We're here to test the reaction control system. We have to get the cameras rolling again. So let's do that. And this one is almost out of battery. Oh boy, should I plug this in? I should probably plug this in. Where's my camera bag? This is going really well. Hold on 1 second, folks. I'm going to plug one of these cameras in so it doesn't run out of power. Okay, plugged in. Just going to swap this out really quickly. There's the battery. I don't know why I didn't do this in the first place. Okay, cool. We'll make sure that's pointed correctly. Our water is really not that cold anymore, which is like not the worst thing in the world, but it just won't be that effective. And I don't have enough ice in my ice tray to actually like refill it. Okay, so we're still rolling. We shouldn't still be rolling. And there we go. We've got plenty of space left on that camera, and plenty of space left on this one. I'm also going to change the angle on this guy, I think. Okay. Boy, this is not a very flattering angle. That's rolling. So we're rolling on all three cameras. I'm going to connect this up. Make sure I can see this over here. Okay, perfect. We're still pumping fluid into the pump, although it is now like idling at about 20 degrees Celsius, which I don't love. So we'll probably be able to do maybe like 2 more tests of this, and then I won't feel comfortable running the pump anymore because it's going to get pretty hot. Okay. Wow, we still have a ton of people watching. 355. Thank you all for joining, by the way. I'm not sure if I've said that before, but like, it really means a lot. Safety also means a lot. This video is sponsored by plastic in front of your eyes. Here we go. So we're going to pressurize again. We're going to pressurize the flight tank. I think we will go up to maybe just like 2.5 K. Nothing super crazy. I guess that's pretty crazy. But like, we don't need to go up to 3,000 again. That was more than we need. All right, great. So once again, just to recap, the compressor needs to turn on first. Then you close the relief valves on the compressor once it's running, so you reduce the amount of stress that gets put on the pistons. It's like a staged compressor too, so there are actually 2 pistons you want to protect. That's going to go into our flight tank right here. You're going to be watching the compressor, which is the pressure valve here, or pressure reading here is a little bit off. So we're going to be going off of what the flight tank says. That's going to come through here. We've got our press valve closed, and then we'll open it when we're ready, because once we open it, it goes into a big manifold with a lot more connections. So really prone to leaks on that. We've got a little small leak here, but it's not a huge problem. All right, so we're going to close that. Turn on the compressor. 3, 2, 1. And how many Saturn V's were built but not flown? Excellent. All right, so we can hear that leak again. Jaden Walters, by the way, got the answer to that one. How many Saturn V's were built but not flown? The answer is... Oh my gosh, no, he didn't. Built but not flown is actually... So far, a lot of answers are 3, but that is not correct. Justice Long gets it with 5. There were 2 Saturn V's that were built after the program that were not flown and then taken apart. Or sent off to museums. Okay, we're losing pressure here, which is okay. Once again, we have that lower D gain, so I'm going to go ahead and turn on the computer. We're going to start it at just a slightly pitched over angle. And 3, 2, 1, press. Okay, we're pressed. Not bad. It seems a little less aggressive. All right. It seems a little bit less aggressive than last time, which does make sense because we lowered the D gain. So now we're going to bring the D gain up. All right. We're going to bring the D gain up, which means we are also going to, well, first we have to reprogram the D gain. So I'm going to turn the computer on again. We are no longer pressed for flight or even testing. Okay, so the D gain was 0.012, or it was 0.008, and now we're going to go to 0.016. Cool. So this is now roughly, I don't know, I'm not counting, but it's a comparable thing to going from the original values that we used at the beginning, and instead of going down that amount, we're going to go up the equal amount. So we're sort of straddling these gains that we started with. We've done the test that is below the D gain. Now we're going to go above, so this should be very aggressive, and if I'm being honest, I think it will probably pitch itself out of control. It might be able to hold position, but I think it's going to be, it will be more difficult for it to hold position. Okay. Here we go. So once again, let me make sure the cameras are rolling. That looks good. One of them is overheating, but whatever. We have multiple angles here, and we have like the whole live stream to pull from. So the pump is at 25 degrees Celsius. I'm not like incredibly comfortable with that, but I think this is probably the last time that we're going to pressurize the flight tank on this stream. just because I'm running out of cold water to cool the pump off, and you really don't want to mess with this pump. It's it's not delicate necessarily. You just don't want to push your luck when you are dealing with pressures in the thousands of pounds per square inch. Okay, great. We're connected up here. We are closed on the press valve. So once again, we're going to turn the compressor on and then close the relief valves on the compressor. That will start pressurizing the flight tank. And I don't know, you guys, you're all familiar with what's going on at this point. Here we go, 3, 2, 1. Oh, and let me pick a trivia question to do. Let's do this one. Okay. Ready? Here we go. In 3, 2, 1. Watch out, ears. All right, here we go. Which Saturn V launch was the heaviest off the launch pad? $1,000. Shut down on the compressor right as it reaches 50 degrees Celsius. So we're still leaking there. I'm just going to quickly see who got the Apollo answer. It was which Apollo launch was the heaviest? Colin Dietrich gets it. Thank you, Colin. By just putting in a 1 and a 6. It was Apollo 16. Thanks to Charlie Garcia for that information, by the way. It was apparently 7,000-ish pounds heavier than Apollo 17. Okay, great. Here we go. We're going to turn the flight computer on. I'm going to take this off. So this is the stronger D gain now. So this should be perhaps a little too aggressive. So we're going to idle for a little bit. And we're going at about 2.5K PSI. Compressed. It's a little bit more aggressive now. It's still not that bad though. So we're pretty flexible in terms of the gains we can use. Wow. Oh. It'd be like that sometimes. Wow, all right, that's great. So that's it. Let's go ahead and close the press valve, turn the flight computer off, take this out and open the press valve. Cool. So now the tank is open to the environment. We're just going to let it sort of sit there for a little bit and do its thing. Let me turn off these cameras. Stop recording. Stop recording. And stop recording. Great. Okay, now I think I'd like to do... Well, no, we're not going to do a leak test because we already have leaks in the system that I know about, and they weren't there before, so I can definitely get better Tefloning on my connections before I do a leak test. Anyway, okay, let's check out the chat. Let's see what's going on. We can take these off too. I hope the compressor is cooling. Yeah, all right, 28.5, so the compressor is definitely cooling down. We're going to keep running that water through there, though. Okay, so what else is going on? I got a couple more trivia questions if people want to do those. This is a pretty fun stream. I really like this. I like the live testing thing. Sometimes people ask about whether I can stream like actual launches, and it's a lot harder to do out in the field because I basically just have my phone and I just sort of splurged on a better internet connection, and I'm not about to splurge on a better phone connection at the same time. Anyway, it's quite a lot of work to do the streaming, but if it's just going to happen inside of my place, it's not too hard to do. Anyway, let's get some questions. Oh, well, let's do one more trivia thing, and then we'll take some questions and see what's going on. So, here's the question. Oh, wow, thank you, Kyle. Thank you for all the great content. Well, thank you for the donation. All right. The question is as follows. Once again, the first one to get it right wins. Now, the criteria for getting it right here is a little bit different. Hold on, sorry, I have to adjust all these things. The criteria for getting it right here is slightly different than before. What I'm going to say is, in order to get this question right, you have to say, you can't just, you have to give like a coherent answer, not just like the term for what may or may not have been missing on this launch. I'm just going to say it, and I'll pick whoever gets it. Here we go. So, the question is, Apollo 4 was super loud. Why? That's the question. The answer is not dear, Justice, but good try, for sure. Okay, Nolan says they didn't, which is not completely the answer. Grim Creeper says no water. I'll give you like a quarter point for that, because it is kind of correct. Yeah, Mr. Toaster gets about 0.8 points. No deluge system to kill the sound. You are correct. The spelling on deluge is pretty, well, it's lacking. But yeah, I think Joey Murphy, nice name, Joey, gets it right the most, which is lacked the water dampening system. So the sound suppression system was not on for the first launch of the Saturn V, which was Apollo 4. And it was quite loud. Okay, let's do another one here. So this is another one for my buddy Ian on Twitter. Thank you, Ian. The question is, which Apollo flight had the service module painted white? That's the question. Which Apollo? Oh, no. So far, no one has it. A lot of answers, but I think Matt Soup gets it with 6. And I will count that. It's Apollo 6 that had the service module painted white. Okay, great. Good trivia. Good trivia. Let's take some more trivia. I asked people on Twitter to DM me some trivia, so I'm taking live questions now. I'm going to go ahead and let you know that I'm not completely fact-checking these ones that I'm about to give you. I'm just sort of reading them off of Twitter. So let's see. Oh, my goodness. It's Francisco from earlier. Thanks for DMing me, Francisco. There's a question about the cue ball. Let's see. Okay, hold on. I'm looking for trivia live. I'm finding that I was less prepared for the trivia than I thought I was. All right, here's one from my buddy Charlie Garcia. So if Charlie answers this, we're not going to count it because he gave me the answer. This one is, I think, going to be pretty tricky. We're going to say that it has to be in pounds. This measurement must be in pounds. I know what it is in kilograms, but you have to put it in pounds. All right. So here is the question. So this is not in reference to the whole instrument ring on the Saturn V, but how much specifically did the launch vehicle guidance computer weigh? The launch vehicle digital computer, how much did it weigh? In pounds, just the digital computer, not the whole guidance ring. Just the digital computer. Wow, there's a lot of guesses here. None of them are very close. Here's hoping... Oh! Someone is close. Oh... I might count this. I'm going to count this. Stephen Bork. You are very, very close. I think... Okay, we're going to pick a couple of winners for this one. And the winners are Steven Van de Kamp, Stephen Bork. Good for both of you for coordinating your names. They both answered right around 75 pounds, and that is about correct. Charlie told me it was 75.2. One of you answered 75.5. I will count that. Oh, wait, 72 is a lot of them. Maybe it's 72. I don't know. It's pretty close. If you answered 70-something, I'll count it. I wonder if Charlie's still here. I don't see Charlie in the chat. Maybe he can confirm. Google says 72 pounds. Let's look. Let's just Google it. How much did the Saturn V digital computer weigh? Is it fun to just watch someone Google stuff? 72.5. I wrote it down wrong. I wrote 75.2. But yeah, so the first two people who answered were basically correct. All right, do I have any more trivia questions here? I think I have at least one. All right. Earlier, I gave a question about which company built the guidance system for the Redstone and the Saturn I, but only for the first 4 flights. The answer was Ford. After the first 4 flights of the Saturn I, what company started building the guidance computer? And it's not Ford. What company did they switch over to? And it's U.S. water rockets right away with IBM. That was extremely quick. You got it. Wow, a lot of people are getting these. Like, even if you don't get it first, everyone seems to know these things. So good job, everyone. We're all winners. That is all of the trivia that I have for you folks. And now we're in the part of the stream where I don't know what to do anymore. So now you're just watching someone talking, which is going really well for me. And let's see, how long have we been going? Does anyone know how long the stream has been going on? I guess we should do some questions for BPS, just like BPS questions. All right. 101 minutes. That's not too bad. So let's do some BPS questions. If you have any questions for me, just put them in the chat, and I will do my best to answer them. I know the view is a little weird here, but I don't care. Which FRC team were you on? FRC stands for First Robotics Competition, which is an awesome competition for high school students to get into engineering. And it's definitely what helped me get into engineering. I was on team 2888. We were called the Beaver Bots, and it was awesome. Our team wasn't very good, but that's not really what it was about. First is really good for getting you hands-on experience working with a team of engineers who are all trying to work toward a common goal. And there's nothing that is more fun than that. So 2888, but also lots of extra information about First Robotics. Let me just try to get some of these other ones. When will FH launch again? What a great question. Let me get it. Hold on. The Falcon Heavy is all assembled over here. It's bigger than you think. It's quite a large rocket. So, does this fit in the frame? Probably fits close to it. So it's if I'm sitting down, it's taller than me. That's the Falcon Heavy. Wonder if I can just like let it hang out there. I'm gonna lean it up on the side. So when will FH launch again? Here's my schedule. Okay, there's at least 2 videos coming out in like the next week or so, maybe 2. One of them is the reaction control video coming out in a few days. Then I have to cover Scout D1F3. That's the 3rd flight. That is the hot staging flight, which is super cool, by the way. And then I'm going away for about a week. And then I think when I get back, I have to ship out a bunch of signal kits. That's probably going to take a couple of days. I might focus on landing again. I don't know. Falcon Heavy is not a huge priority, which is sad. But like the thing I'd rather focus on right now is landing and also finishing up the signal stuff, because signal's going offline for a little while, and so it's important that I get that done. Okay. What is your favorite color? I don't have a favorite color. What is the hardest thing to complete on which? What was the hardest thing to complete on which rocket? You know what was really difficult, like surprisingly hard, was getting vehicle integration done for the valves and flight computer and everything here, because you can't change the plumbing once it's inside the vehicle, so you have to get your plumbing right, secure all your plumbing, cut all your tubes to length, and then like get it inside the vehicle, and the tolerances were really tight on these valves. So it was really difficult to like get this stuff screwed into the airframe. Where do I live? Nashville, Tennessee. Have you ever considered using a solid rocket motor for control? I am referencing the solid rocket motor used on the Orion capsule that can be used for control. It has a similar system to the reaction control system. Aaron, great question. Yeah, reaction control via solid motors is totally a viable option. It's a little bit more complicated, and you need... Well, okay, there are 2 ways you can do it. You can do it like the Orion launch abort attitude control system, which basically is one solid motor constantly burning, and you have a mandrel or some, I don't know what you want to call it, in the middle that moves around and opens up different ports. It's like one big valve that like moves around and opens up different ports. So if it's in the middle, you get equal force on all sides. If you like circle it around on the inside, you should look it up. The Orion abort attitude control system. It's pretty cool. I imagine it would be tremendously hard to get it to work at a model scale. I think it would be unbelievably difficult to get that type of system to work at a model scale. What would work really well is using a set of perhaps like D-level motors on a high power build that can fire pretty fast. So you want like a core burner ammonium perchlorate engine, and you do like 20 of them. You do like 20 of them around the airframe, and it's basically how the Patriot or the PAC-3 missile actually does its terminal guidance phase. So instead of having a pressurized working fluid for reaction control, it actually fires a bunch of these tiny little motors to make corrections near the end of flight. Okay, I'm missing a lot of questions. Thank you for putting in your questions. If it doesn't get answered, just like keep putting it in, maybe like 2 or 3 more times. I'm going to try to keep the answers short. When will there be another landing test? Says Grim Creeper. I'm really excited. Once you land on grass, try landing on the road. A more even surface should be nicer. Okay, so when will there be another landing test? Maybe within a month? Yeah. What day is it? Probably within a month. I don't really know. I have to do a little bit more work on the flight data from the landing test, but probably within a month. Can you show us more of your compressor workbench from another angle? Okay, yeah, great. I can definitely do that. Well, how do I do that? Okay, I'll just use this camera. We'll see how well this works. But basically, we've got this whole workbench here. It's not super crazy. That's the water bucket where the... what do you call it? The ice was, and the ice no longer is. The water bucket goes into the high pressure compressor right here. The compressor goes into the thing. It's not super complicated. How does that look? That looks all right. Okay, what else? All right. Will you ever use CO2 for propulsive landing? Probably not. Jordan, I think I answered your question on Reddit the other day too. CO2 is not going to work for propulsive landing unless you have a tremendous amount. Like the energy density is just not going to work out for that. What was your background? My background was this. Berklee College of Music. That's my degree. Oh my gosh. So many questions. Thank you for your questions, by the way. I am missing all of them. Where do you think BPS.space will be in 10 years down the line? I don't know. I would hope that I get to space at that point. I would hope that, like, within 10 years, I'm able to do a successful space shot, not with me on board, but, like, send a rocket above the Kármán line. I think that might be conservative for 10 years, but I really don't know. Like, things have kind of taken off in the last few months, pun intended, but I don't know if that'll last. Like, we'll see. Maybe it'll just sort of fizzle out. I'm going to try not to do that, but, like, we'll see. Okay. What happened to the Falcon Heavy upper stage? It's right here. It's just chilling. It was fine. I mean, it didn't fire the motor because it decided to abort the flight. What is your experience with SpaceX? I watched their live streams. That's my experience. Why don't you use Arduino? I don't know how much you know about my work, but I use exclusively Arduino. All of my flight software is built in the Arduino environment. Take a look at the website, bps.space/avionics. Okay. Let me try to find some more. I'm like scrolling up. What do you think about raccoons? A terrible idea. Don't do it. Balloons can't be controlled. Like, it's so... Every company that I've seen try to make raccoons work as a viable orbital launch concept is... I don't mean to, like, hate on anyone, but it's just not a good idea. Like, you're adding so much It's fine. I'm not going to complain about this. You're adding so much complexity, and it's an inefficient way to get to orbit. How are you calculating your PID settings? I'm trying to do a bit using Scilab, but I find it hard for adding and subtracting. I have a flight simulator that I built in Simulink, which is a part of MATLAB, which is an engineering tool. It's super intense. It's not super intuitive, but it's really, really good, and that's how I do it. So I just do a lot of experimenting on the ground, try to simulate all of the different forces that this vehicle sees during flight. You also want to measure your mass moment of inertia of the rocket, so that's like how much force is going to change the direction on the vehicle. I'm doing a bad job describing this, but there are a couple of videos on this channel about that. Okay. Have you ever planned on making your own engines? No, I don't do that. I got a C+ in chemistry in high school, so building my own motors is not the move for me. Will you use hypergolics? Absolutely not. How do you plan on landing on a targeted landing pad? I do not, Alex. What? Okay, hold on. Will you get your NAR level 2 anytime soon? I hope to do that this summer. Nathan Smith says, MATLAB kicks my butt. Do you use Open Rocketry for your rockets? Steven, I think you mean maybe Open Rocket, but yeah, I totally do. Open Rocket is awesome. I'll probably simulate part of the stability on this vehicle in Open Rocket. Not the active part, but the passive part. The reaction control vehicle is going to be passively stabilized with just regular old fins, but it's also going to launch fairly slowly without a launch rod, so the reaction control will be required for flight. Okay, what 3D printer do I use? Brian, you should check out the website, man. All of this information's on the website. Will you create a liquid hybrid rocket in the future? I don't like hybrid rockets. You should check out the video on propulsion types on the channel. Okay, I'm going to take a couple more questions here. What is the Falcon Heavy made from? Pretty typical tubes. These are 3-inch thin wall tubes that you can get from like Apogee Components. I use these for almost all of my vehicles. The reaction control vehicle, because it's like kind of a beefy thing, is actually called blue tube. So it's a much more dense and stronger material. It's a little heavier, but this stuff is not going to break unless you do something really wrong. Why didn't you add the nose cone onto the test today? So, Owen, the nose cone is right here. This is actually what it will look like once I mount the nose cone on. But I didn't use the nose cone today just because I already have this all wired up and plumbed, and the valves are nearly identical. The only difference is where the roll control thrusters are located, but we're not even using roll control for these tests. So I think, I'll probably put this on maybe tomorrow or something like that. Okay, am I interested in water rockets? I'm not personally interested in water rockets, but I think they're super cool, and they're a really fun way to safely get into rocketry too. Okay. Are you ever planning on going back to college for engineering or another degree? The deal with that is I'm quite happy doing what I'm doing right now, but it would be really foolish to say no. It honestly just depends on how the next few years pan out. It might super be a good idea for me to go back to engineering school. And if I end up working with a larger company if I end up working with any larger aerospace company that's doing serious work and actually going to space, going back and getting my degree in an engineering type field is going to almost certainly be required. Now, I can tell you from experience that a lot of companies are really willing to send you back to school and help you go through that process. So the answer is I don't know. Can you do another RCS test? Not right now, because we ran out of cold water to put through the pump, and I don't want to stress the pump too much without a proper cooling system. Sorry, I just saw one that I wanted to answer. Where did it go? Oh, here it is. Are you making a living from BPS? Yes. This is a great segue into the plug. I am making a living from BPS, and it actually it's working, which is surprising because it didn't work for a really long time, a really, really long time. But it's working now, and it's thanks to all of the folks who support BPS.space on Patreon. I'll do my little spiel here, but there's a link in the description down below. All of that is what allows me to do stuff like this. I would not have been able to take on this project, financially speaking, with the compressor, all the valves, all the regulators, the flight tank, these new cameras, all of this stuff. None of it would be possible without the people who support BPS on Patreon. So anyway, if you're interested in that, there's a link in the description. You know how this works. If you're not, it's totally fine. I'm happy to have people follow along, so there's no requirement for it. How is ARC coming along? I don't have excellent news about that. Orbital Redenbacher, which is, by the way, an amazing name. ARC is kind of in a freeze right now. I'm trying to figure out what BPS is good at and what I want to do for the next few years. And ARC is in a confusing space right now. So the answer is ARC is kind of on hold, which I'm sorry is a little bit disappointing to hear, but I'll probably know more about it soon. Sorry. Okay. Let's take a couple more here. Would you consider... Oh, Aaron! Yes. Aaron G. asks, would you consider making an air launch rocket? So, I think in the way that you ask this question, the answer would be no. But it segues into something that I want to do very, very badly. So air launching a rocket is, I think, you drop it from a model plane or you drop it from a balloon, which again I think is a bad idea. But I do want to take on a project to silo launch a rocket, which is called cold launching. And so what happens is, well, it is exactly how most ICBMs are launched, which is not a wonderful thing to think about, but it's a super cool engineering challenge. And so what you do is you have a silo, you have a tube, a big tube, and you have, I don't have an immediate launch vehicle I can use for this, but basically you have a tube that is either sticking out of the ground, or it's in the ground. For our case, we just have it be set on top of the ground. You have a tube with a piston, probably air pressurized, probably another one of these flight tanks on the ground, and then really, really quickly, all at once, you pressurize the piston, you shoot the rocket out of the tube without lighting the motor, it hangs in the air for just a second. It like goes, thump, and then it lights the motor. Like as it comes up near an apogee, it fires the motor. So you don't, like your launch pad doesn't have to tolerate super high heats or like forces, because you like shoot the rocket up in the air and then you turn the rocket on. It's pretty cool. I think I'd like to do that. Okay, there's an answer to something that someone named Dare. Do I ever use Raspberry Pi? I have not used Raspberry Pi yet, but it's a cool platform. That was the best thump sound I've ever heard. Falcon Heavy silo launch is not going to happen. You think Everyday Astronaut will ever come out to a launch, or would you let him? I would totally let Everyday Astronaut come out to a launch. Tim and I are buddies. I feel like people think that we don't know each other. It's a weird thing to say that. I don't know how to say this in the right way. Tim and I are like good friends. So if he's ever in Nashville and I'm doing a launch, like he's totally welcome. Why aren't you? Oh my gosh. Why aren't you using a hypergolic engine? It should be simpler to build. I think you underestimate the carcinogenic effects of most hypergolics and the simplicity of liquid bipropellant rockets. I think that might be it. Oh, wait, hold on. If someone were to join BPS, what role do you think they would play in the company? When will someone join? That is a thing that is in motion right now. Things are just in a lot of flux, in a good way, with the business. But I don't want to like have anyone else be relying on me for work until I really know that things are like stable and can provide it. Honestly, a lot of that has to do with the Patreon stuff. But I think, it might happen this year. We might be able to bring someone else on, and if we do, I don't know what role they would play. They would probably have to play a lot of really flexible roles. It would not be something specialized. Yeah. It would be great to get someone who could edit video too, because editing video takes a long time. Would you ever consider internships? Yeah. Yeah. Sorry, I want to say more. I just haven't figured out the specifics of this yet. Okay. Folks, I think that might be it for today. Thank you so much for joining. I know this is a different stream, but thank you so much for joining. The video for this will be up in probably a few hours, maybe even less because it's under 2 hours long, but the video of this will be up so you can watch it afterward and see these reaction control tests. But if you are just interested in the tests themselves, I'm actually going to put together a more concise and probably a little bit more thorough video about how these tests look. I'll probably do a couple more offline, and that'll be up in maybe a couple of days at the maximum. So that's it for now. Hold on, I gotta go back to my computer. 1, 2, 3. Okay, yeah. That is it for now. Thank you everyone so much for joining. It means a lot to me, and it's easy to say thank you, but it does truly mean a lot to me. And it's like you're here, and it's the reason that I get to do this stuff. So that's it. I'm really good at streaming and ending live webcasts. My name is Joe Barnard, and everyone type it in the chat with me. My name is Joe Barnard. May your skies be blue and your winds be low. Goodbye, everybody.